You've heard of both the x and y intercepts before. The x-intercepts were the locations where a graph touched the x-axis. The x-intercepts are also known as the solution of a particular equation. A lot of times when we solve an equation, we're solving for the x-intercepts. They are also known as zeros, roots, and solutions. These are just different ways of asking you to find the same thing. And then a y-intercept is the point or points where a graph hits the y-axis. It can be done algebraically for certain types of equations. We'll talk about that in another time. But a lot of times you're just going to graph a function on your calculator and you're going to locate it yourself. So let's work with a simple quadratic equation and find both the x and y intercepts. You're more than welcome to plug this into your graphing calculator and look at what the graph looks like. Here's a picture of what the graph of y equals x squared minus 2 looks like on my calculator. The calculator I'm currently using is the TI-83 Plus. However, I highly recommend that you have some version of the TI-84. It has a lot more functions on it. But for the purpose of what we're doing here, this is the easiest way to do it. If you look at this graph, you'll notice that the x-intercepts are between 1 and 2, because each tick mark on the x-axis represents 1. The default window setting on the graphing calculator is 0 to 10, 0 to negative 10 on the x-axis, and 0 to 10 and 0 to negative 10 on the y-axis. And you'll also notice that the other x-intercept is between 1 and negative 1 and negative 2. There is a function on the calculator to help you find the intercepts, but sometimes the answer you get is irrational. That's a non-repeating, non-terminating decimal. So we'd prefer to find the exact answer using algebra. So you find the x-intercepts by plugging in 0 for y and solving for x. Because the x-intercepts, where they hit the x-axis, the y-coordinate of both of those points is 0. So if I plug in 0 for y, I'm going to get 2 equals x squared. So x must be plus or minus the square root of 2. And the square root of 2 is an irrational number. The y-intercept, you may be able to tell it's at negative 2. If you can tell on the graphing calculator where it is, great. Or the other way of finding the y-intercept is the y-intercept is where x is 0. So if you plug in 0 for x, you're going to find out that y is negative 2. In geometry, we studied circles. You probably talked more about area, circumference, sectors. You probably talked about tangent lines, maybe secant lines. We're going to use in this course the equation of a circle. We're going to go over this again in our study of conics, but this is a nice introduction because it is in the prerequisite material. So here is a circle on the coordinate plane, where we call the center of the circle C, and we usually call its ordered pair H, K. You're going to see that pop up a lot. As a matter of fact, when we studied parabolas in Algebra 2, you might recall that we called the vertex of the parabola H, K. Keep that in the back of your mind because it's going to come back to haunt you. Any point that lies on the outside of the circle, P, we're going to call x, y, and you know the distance from the center to the point on the outside is the radius. Well, if I wanted to know the length of the radius, I would use the distance formula. We talked about the distance formula already. Remember, the distance formula is the distance between 2 points is the square root of one x coordinate minus the other x coordinate squared plus a y coordinate minus the other y coordinate squared. But instead of using d, we're going to use r. And it turns out that this equation is the general equation for a general equation of a circle. R squared is x minus h squared plus y minus k squared. So as long as you know the distance formula, you can derive the equation for a circle. A lot of times we talk about circles whose center is at the origin. So what if the center of the circle was at 0, 0? Well, we just said that the center of the circle is hk. If that's the case, then if h is 0 and k is 0, then we find out that this is the equation of a circle whose center is at the origin. This formula, very important. It will come back when we study polar coordinates later in the year. For graphing a circle, we're not going to use our calculator. It's not that you can't do it on the calculator, it's that it requires you to solve this equation for y, and then you're going to get two equations, and you're going to have to graph both of them, and then when you graph it on the calculator, you're going to get these two half circles, and the half circles aren't going to connect, and you're going to wonder why they don't connect, so we just don't do it on our calculator. It's really easy to draw these circles by hand because you only need to know two pieces of information. Those two pieces of information are the center and the radius. Well, remember, this is an equation of a circle whose center is at the origin, so the center must be at 0, 0. Remember that this is r squared, not r. So you have to take the square root of it to find the radius. So once you know the center and the radius, to draw the circle, what I would do is I'd put a little dot at the center just to remind me. Well, remember the radius of all radii of a circle are congruent. So if I go 5 units to the right, 5 units to the left, 5 units up, and 5 units down, there's my circle. Yes, I realize it's a poorly drawn circle, but you can use your imagination. So let's do this again. In part B, you have to be careful because the general equation is this. So if the center is at h comma k, in this case, h is 2, but k is negative 1. The reason k is negative 1 is because you'll notice that in the equation I gave you, the sign of k is the opposite from the general formula. And the radius is 5. So what I'm going to do here is I'm going to start by going to 2, negative 1. Here's my center. And I'm going to do the same thing that I did in the last problem. From the center, I'm going to go 1, 2, 3, 4, 5 units to the right. I'm going to go, let's see, oops, let me get rid of this so it doesn't look like another dot. 1, 2, 3, 4, 5 units to the left. I'm going to go 1, 2, 3, 4, 5 units above, and 1, 2, 3, 4, 5 units below. And there's my circle. Now let's do a problem where we're given information about a circle and we want to find its equation. So if I tell you the center and the radius, writing the equation is easy because all you need to remember is that x minus h squared plus y minus k squared is equal to r squared. So the equation of this circle must be x minus 2 squared plus y plus 5 squared. Why did I change the sign? Equals 9. Remember, it's r squared, so I have to square the 3. And then b just magically appears. So in part B, I'm going to give you 2 points, P and Q, that are the endpoints of a diameter. So P is at 1/8, Q is at 5, negative 6. Let's find the equation. Well, remember I told you there are 2 things I need to know. I need to know the radius, and I need to know the center. Well, how am I going to find the center? Well, if you think about this, let's see, where would 1/8 would be, like up here somewhere. And then 5, -6 would be down here somewhere. So I'd have some graph that looks like this. This is my diameter. How do you find the center? Wait a second. Isn't the center of a diameter the midpoint? Oh, maybe I'll use the midpoint formula, and that's how I'll find the center. All right, the midpoint formula, remember that was the one that said you add the x's and find their average. You add the y's and find their average. So the midpoint must be at 6/2 is 3, and 2/2 is 1. Well, I know h and I know k. Now I have to find the radius. The radius is going to be the distance from either C to P or from C to Q. It doesn't matter which one you pick. So, for no apparent reason, I'm going to pick these two. So, if the radius is a distance, then the radius must be the square root of one of the x values minus the other x value squared, x value, plus the y value minus the other y value squared. And then I'm going to simplify that. So I'm going to get r is equal to the square root of -2 squared plus 7 squared, which is the square root of 4 plus 49, which is going to be the square root of 53. The square root of 53 is not an integer, so I'm actually going to leave that as the final answer. The reason I'm going to do that is because the circle equation squares r at the end. Well, what happens when you square a square root? They cancel each other. So x minus h squared plus y minus k squared is going to equal r squared. This will be the equation of the circle. Let's take that previous answer and expand it out. When you square x minus 3 squared, you're going to get x squared minus 6x plus 9. When you expand y minus 1 squared, you're going to get y squared minus 2y plus 1. And then I'm going to rewrite this in descending order of powers. So I'm going to start with x squared plus y squared. And then I'm going to put minus 6x minus 2y. And then I'm going to combine the constants because they're constants, they're combinable. 9 plus 1 is 10. And then I'm going to do one last thing. I'm going to set this equation equal to 0. So I'm going to subtract the 53. This is called the general equation of a circle. And I gotta remember what letters we use. Let's see, cx plus dy plus e equals 0. We're gonna learn how to take an equation that starts in this expanded form, which is not usable in any way, shape, or form, because how do you figure out what the center and radius are? And rewrite it so that it is in the usable form, called the standard form. So in example 10, let's look at this equation of a circle that's in this general form. Well, I don't know what the center and radius are. Here's how we put it together so that we can find it. We're going to use a process called completing the square. You may or may not have done this in Algebra 2. What I'm going to do is I'm going to start by putting the terms with the x's together, and then I'm going to leave a blank. And then I'm going to put the terms with the y's together, and I'm going to leave a blank. I'm going to move the constant to the other side. Notice it becomes negative. But I'm going to add 2 blanks over to the right-hand side. Remember that one of the rules about equations is that you can add numbers to either side as long as you do it to both sides. So if I add two numbers to the left side, I have to add those same two numbers to the right side. There are more complex methods of doing this. We'll get to those when we study conics. But we'll start with this simple version. We're going to create a perfect square trinomial. A perfect square trinomial is one in which the middle term is a number plus itself, and the last term is that same number times itself. Well, isn't this 1 plus 1? In order for this to be a perfect square trinomial, this needs to be 1 times 1. It doesn't matter at this moment in time if the term in the middle is a positive or negative. So for the y parentheses, isn't this 3 plus 3? 3 times 3 is 9. It will always have a third term that is positive. The reason is because really what's happening here is I'm adding negative 3 plus negative 3, which is negative 6. Negative 3 times negative 3 is still positive 9. Once you've created these perfect square trinomials, we talked about factoring these in an earlier video. This is going to be y plus 1 squared. The second, try that again, that's going to be x plus 1 squared. The second one's going to be y minus 3 squared. And negative 7 plus 1 plus 9 is going to be 3. So now I know the center of this circle is at negative 1 comma 3. Remember, opposite. And the radius is the square root of 3. The last thing that we're going to talk about in this particular section is something called symmetry. Again, symmetry is a concept you ran across in both geometry and algebra 2. And I'm going to approach it a little bit different than the prerequisite part of the textbook does, because I think this is a better way of doing it, but that's just my opinion. When a graph is symmetric about the x-axis, if xy lies on the graph of a function, then x negative y must also lie on the graph. If a graph is symmetric about the y-axis, which many quadratic equations are, if xy lies on the graph, so must negative xy. Some graphs are symmetric about the origin, particularly circles whose center is at the origin. So if xy is a point on the graph, negative x, negative y also on the graph. And one we'll focus in a little bit more at another point is symmetry over the line y equals x. When we talked about inverse functions, we were talking about symmetry over the line y equals x. So if xy is on the graph, so is yx. Basically that means that you take the order pair and you reverse it, and that order pair is also on the graph. So how about if I give you the point 2, 3? And I said, what is the point symmetric over the x-axis? Well, you should tell me that it's 2, negative 3. Because symmetry is like a reflection. It's like if the x-axis were the line that I folded my paper over. When I folded my paper, where would the red dot lie? It would lie on top of the blue dot. All right, how about if I said, where is the red dot if it's symmetric over the y-axis? Well, if you fold a sheet of paper over the y-axis, you should find that it's over here at negative, try that again, negative 2, 3. I've got too many dots happening here. There we go. If my point is symmetric over the origin, so the origin's not a line, it's a dot. But if it's symmetric over the origin, then it's going to be down here at negative 2, negative 3. And then if I want it to be symmetric over the line y equals x, the line y equals x is the line that goes through 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. So if I fold my paper over that line, 2, 3 would end up at 3, 2. Now, In example 11, we're going to use symmetry to help us sketch the graph of x equals y squared. Now, for the most part, most of you are probably saying, well, why would I need to do this? Why can't I just shove something in my graphing calculator? Well, there are two things happening. Number one is, you got to be good with the graphing calculator. Some people don't know all the functions on the graphing calculator. We're going to teach you a lot more functions on the graphing calculator this year than you even came across in Algebra 2. The other thing is, what if this is the problem on the state testing? And the state testing, you can't bring in a calculator. You only get to use the calculator on the computer program when it allows you to. So what if they wanted you to sketch this graph using the computer? They don't give you a calculator function. What are you going to do? Well, we can use symmetry to help us out. First of all, I want to point out to you that the biggest exponent is a 2. That means that this is going to have a parabolic shape. That doesn't mean it's necessarily the parabola that you're used to, because we're used to problems where x is squared. In this problem, y is squared. But I can tell you, if there's a square term and it's the biggest exponent, it's going to have some parabolic shape. It's going to have this U shape somewhere on the graph. All right, let's do something else. Let's find out what our symmetries are. So, is it symmetric over the x-axis? Well, let's find a point that actually lies on this graph. Let's start with, let me erase that for a second. Make a little table here. What if x is 0? Well, doesn't y have to be 0? So we know that the origin is a point on this graph. Well, since y is the value being squared, if y is 1, then doesn't x have to be 1 because 1 squared is 1? And what if y is 2? Doesn't x have to be 4? And if y is 3, doesn't x have to be 9? So that gives us a starting point here. 0, 0, 1, 1, 4, 2, 6, 7, 8, 9, 3. So I at least know that the graph is looking like this. Well, guess what? Most of you can probably figure out at this point in time that the other part of the graph is going to look like this because it's got to have some sort of parabolic shape. But let's talk about symmetry here for a second. I'm going to use, we'll use this point. So if the graph is symmetric about the x-axis, if 4, 2 is on the graph, then 4, negative 2 has to be on the graph. Well, is it? If I plug in 4 for x and negative 2 for y, is that true or false? Well, it's true, because when you square a negative, you get a positive. So it must be symmetric about the x-axis. Then let's check symmetry about the y-axis. If 4, 2 is on the graph, then negative 4, 2 would need to be on the graph. So if I plug in negative 4 for x and I plug in 2 for y, is this true or false? Well, that's false, because whenever you square something, you're always going to get a positive as its output. Is it symmetric about the origin? That means if 4, 2 is on the graph, then negative 4, negative 2 is on the graph. Well, is negative 4 equal to negative 2 squared? No, because negative 2 squared is also positive 4. And is it symmetric about the line y equals x? That means if 4, 2 is on the graph, so is 2, 4. So is 2 equal to 4 squared? No. So the only symmetry was the x-axis. That means that if you take the red part of the graph that you found by just finding a couple ordered pairs, if you fold it over the x-axis, that part, that graph, the red graph, will lie on top of the other side of the graph. Another way of determining symmetry, and this is what we do with the regular pre-calc class, is we say, okay, if we want to test symmetry over the x-axis, then if I plug in x and negative y, I will get the same equation that I started with. So that means that negative y would need to equal x cubed minus 9x. Well, it doesn't, because if you plug in a negative y, and then we don't like negative y, so we divide everything by negative 1, it changes the signs of everything. So we say it's not symmetric over the x-axis because it changes the original equation. How about the y-axis? Let's make that look more like it says y. If it's symmetric over the y-axis, then if I plug in negative x and positive y, I'll get the original equation back out when I'm done simplifying. So that means y is equal to negative x cubed minus 9 times negative x. Well, whenever you cube a negative, the outcome will always be negative. And negative 9 times negative x is going to give you positive 9x. Well, that didn't work. Well, the x-axis and y-axis didn't work. Maybe the origin will work. Symmetry over the origin means if you replace x and y with negative x and negative y, you'll get the same equation you started with. So let's try that. Alright, so negative y is equal to, we just said if you cube a negative, you get a negative. Negative 9 times negative x is positive 9x. But we don't like negative in front of y, so we're going to divide everything by negative 1. And look at what we get. Cha-ching! I got symmetry. So that means that this graph must be symmetric over the origin. So if I go back and I find a couple of ordered pairs, like, I know if x is 0, y is 0. If x is 1, let's see, y is going to be 1 minus 9, which is negative 8. If x is 2, I'm going to get 8 minus 18, which is negative 10. So if it's symmetric over the origin, that means that the opposite of x and the opposite of y must also be on the graph. So if I start with 1, negative 8, that means negative 1, positive 8 must be on the graph. Negative x, negative y doesn't mean make them both negative. It means change the sign of both. So if 2, negative 10 is on the graph, then negative 2, positive 10 must also be on the graph. So now if I go and I draw a quick sketch, and I'm running out of space, so I probably should do it down here. I know that the graph lies on 0, 0. We said, let's see, 1, negative 8. 1, negative 8 is on the graph. Therefore, negative 1, 8 must be on the graph. Let's see, 2, negative 10. 2, negative 10, which means that negative 2, 10 must also be on the graph. And it turns out the graph is going to look, it's going to end up looking something like this. You just have to put it in your graphing calculator. And the other thing that's going to happen is you're going to have to learn how to change the window setting on the graphing calculator in order to see the graph, because sometimes you'll graph things and be like, it's not there, or you'll think that the graph got chopped up. In the next section, we're going to talk about how to change the window setting on your calculator so that you can see the entire graph.